Kia ora, Year 12. This question is another one from today's online scholarship calc session. And again, I thought I'd videoed it before, but I haven't. So this is one of these questions where you have to see the way in, or you'll just sit there looking for ages. And I know some of you are going to say, well, how do I know the way in? And the way you get to know the way in is by doing lots of questions, honestly. So when I look at this question, here's what I see. I've got to prove that a product is equal to a sum. Now, I know that integrating products is bad. So I straight away want to be seeing that on this side, I've somehow got a sum. And on this side, I've got a product. So there's got to be some kind of link up here. So looking at this, if I differentiate this, it might give me a clue of how to start. So that gives me the derivative of that is sine of x over cos of x. And the derivative of this is half times 2 sine of 2x over cos of 2x. Right, so I can see here, and I can get the same thing here. On this side, if I differentiate it, I'm getting tan of x plus tan of 2x. Oops, sorry, minus tan of 2x, minus tan of 3x. So there's something going on that's letting me change this into not quite a sum, but a sum with some subtraction in it. So things are not quite in the right order, but I look at that and then I go back and I look at the first bit and I still can't see anything. So let's clean up all of that mess. And now think about your trig identities. Right? We don't have a nice sum to product thing for tan. And we've got three things in here. So we've got tan of x times tan of 2x. Now what's tan of 2x? Maybe we'll think about that. Well, tan of 2x is 2 tan x over 1 minus tan squared x. So that's not really helping me either. So we can forget about that for now. Then I look at tan of 3x. And hopefully I notice that I've got 3x here and I've got x and I've got 2x here. And we've looked at the double angle formula here, but we haven't thought about the compound angle formula. So tan of a plus b might come in useful. And it does. So we can break up the 3x into tan of 2x plus x. So let's try writing out what that gives us. So tan of 3x is equal to tan of 2x plus tan of x. And then in the denominator, I finally start to get something that might help me because I've got a product in here. And I'm looking at that and I'm still not seeing it, but I somehow want to get those three things times together. So down here, I've got a tan x times a tan 2x. And up here, I've got tan of 3x. So if I multiply both sides by the denominator, look what we get. And on this side now, I've got a sum. So now we're just about finished. Okay, so here we've got tan of 3x minus, look at that, tan of x, tan of 2x, tan of 3x equals tan of 2x plus tan of x. So rearranging that now is going to give me tan of 3x minus tan of x. Which way does the question go, just to be really nitpicky? Minus tan of 2x minus tan of x is equal to tan of x, tan of 2x, tan of 3x. So now I can integrate both sides. I really should have left room for that integral, shouldn't I? Because now I haven't got room for my little dx. Got to have the dx. There we are. And then here we've got the integral of that. And that's what we're trying to get to. So we're doing a proof, so we want to show this reasonably carefully, so don't skip this step. So tan of 3x is equal to sine of 3x over cos of 3x minus sine of 2x over cos of 2x minus sine of x over cos of x dx is equal to this. So I'm actually going to call that I, just to speed things up a bit. Right. And here you can see that we've got our pattern where we've got f dash of x over f of x. So you should immediately at this point in the year be seeing that that integrates to give me a natural log with a little bit of adjustment. So here we get the natural log of cos of 3x. Now when we differentiate that, we're going to have 1 over cos 3x times negative 3 sine 3x. So that needs to have a negative 1/3 in front of it. Here, this needs to have a plus 1/2 in front of it. Whoops, not sine, cosine. Anyway, I think no one's watching at this point because you've basically seen the end. If anyone is watching, they can get a fruit burst when we get back to school if you tell me that you've watched until the end. Right, there we go. So natural log of that plus c as required. I think it's a really nice question because it needs just a little bit of insight. But the insight comes from having done so much work with your trig identities that something triggers in your brain that's the link up that's going to help you out here to get from the product to the sum. So there you go. Email me if you've got any questions or if there are any more questions that you really, really want done. If you're from another school and you're asking me about scholarship questions, I'm pretty slammed with the 5 classes I've got while we're in lockdown, but you never know. If it's one that I'm ready to video, I might have time.